We are already familiar with a way of naming things using constants. For example, here is a constant pi with a value of 3.14. After this line, every time we see pi, we know it means 3.14. It's called a constant because, well, it's constant, permanent. After this line, pi is always 3.14. It won't ever change. This is why in the paper analogy I was using a pen after all. This might seem restrictive, but this is actually rather good. Changing the things we create is difficult to deal with. Imagine writing code using some constant and not being sure it's what you think it is. Nevertheless, sometimes you need to be able to change things you create or change the values, in other words. Say you want to do something 5 times. One way is to do it repeatedly while counting to 5 and then stop. For this, you'd need something to store this counter, this changing number. A constant won't work, it's permanent, you won't change its value after creating. This is why JavaScript and most other programming languages have a concept of a variable. Think of a variable as a piece of paper with a name written with a pen but a value written with a pencil. At any moment you can replace the value with a different one. We can calculate a factorial with a variable like so. Creating a variable is easy. It looks like a constant, but instead of const, we say let. We let it be a thing, and this is not forever. Next, we change the value of factorial. We wouldn't have done this if factorial was a constant. This line means make the factorial be whatever factorial times 2 is. So JavaScript multiplies factorial by 2 and stores this result in the factorial variable. Before, factorial was 1, and now it is 2. We repeat this 3 more times, every time multiplying the number by the next integer, by 3, by 4, and by 5. This is what you might do in your head when multiplying numbers. You probably don't think about it explicitly, but this would be a way of explaining the process if you were to explain it. This idea of using a counter to repeat something multiple times is common in programming, and most programming languages have loops for this. Let's look at one particular type of a loop, a while loop. It's a block of code that is repeated while some condition is met. Think of a farmer who works from sunrise till sunset. He works while the sun is up. You could say, while sun is up, work. This is not valid JavaScript, of course, this is just to give you an idea. This work thing is going to be repeated again and again while the sun is up. This means after each repetition, we need to check if the sun is still up and stop if it isn't. In other words, check, do if it's true, check, do if it's true, check, etc. Okay, so here is the factorial function with variables and a loop instead of recursion. Whoa, what's going on here? First, we create 2 variables, one for the counter, to count from 1 to the upper limit, and the second for the running result. Then the main part begins, a while loop that repeats while the counter is less than or equal to n, the number passed to this function. The code that is repeated is simple. We change the values of our 2 variables. Running result is multiplied by the counter, and the counter itself is incremented by 1. At some point, this condition, counter is less than or equal to n, will become false, so the loop will no longer be repeating, and the program will continue to the next thing, return result. By then, the result will be the answer, because during those repetitions in the loop, the result was being multiplied by 1, then by 2, then 3, etc. until n, whatever that is. Let's see what the computer does step by step when we call factorial of 3. Take one argument, number 3, known as n inside. Create a variable counter, set its value to 1. Create a variable result, set its value to 1. Check. Counter is 1, it's less than or equal to n, so multiply result by counter and put the answer 1 into result. Add 1 to counter and put the answer 2 into counter. Go back and check. Counter is 2, it's less than or equal to n, so multiply result by counter and put the answer 2 into result. Add 1 to counter and put the answer 3 into counter. Go back and check. Counter is 3, it's less than or equal to n, so multiply result by counter and put the answer 6 into result. Add 1 to counter and put the answer 4 into counter. Go back and check. Counter is 4, it's not less than or equal to n, so don't repeat anymore and continue to the next line in the program. Return result. 6. Computer does this billion times faster, but does the same thing. This kind of defined repetition is called an iteration in general. Our program uses iteration to calculate a factorial. Last time we've seen an iterative process with recursion, and this time an iterative process without recursion. Both use the technique of iteration, but with recursive calls, we didn't have to change the values, we just passed the new values to the next function call. On the other hand, this factorial function doesn't have any recursive function calls, so all the transformations should happen inside a single instance, a single function box. We have no other choice but to change the values of things. The style of programming you've seen before this lesson is called declarative. The style of programming you've seen today with changing values is called imperative. Compare a recursive factorial and a non-recursive factorial. This recursive function is declarative. It's like a definition of factorial. It declares what factorial is. This non-recursive iterative function is imperative. It's a description of what to do in order to find factorial. Declarative comes from Latin clarare, to make clear, to announce, to make a declaration. You declare, I want factorial of n to be n times factorial of n minus 1. Imperative comes from Latin imperare. It means to command. You command the steps precisely, multiply this and that while counting down and keep some numbers in mind. Declarative is what. Imperative is how. Writing declarative code is, in general, a better idea. Your code will be easier to read and understand, and it will be easier to build upon. Some languages tend to push you towards one side or the other, and some even leave you no choice, but ultimately you have to learn to see when imperative approach gives you more problems than solutions. Keeping track of changing variables is hard, and even a handful of variables make the system too complex to think about. Many bugs come from the changing state, and assignment statements that perform changes are often the root cause of all the evil in the universe.